Oh yeah! In this video, we're going to go over what happens when you use direct substitution and get an interesting result, namely 0 over 0. We'll talk about that shortly. So, no matter what, when you're given a limit, always start out with direct substitution. So here we've got the limit as x goes to -3 of x squared minus 2x minus 15 all over x plus 3. So, as I said, let's start out with plugging in. So I put in -3, I square it, minus 2 times -3 minus 15, all over. It's more fun to vary your voice when you're doing math. -3 plus 3. Let's see what we get out of that. Well, the numerator, we're going to get 9 plus 6. -2 times -3 is plus 6, minus 15, all over. -3 plus 3 is 0. That simplifies down to 15 minus 15, which is 0 over 0. What? Okay, well, here's the important thing to note. 0 over 0 is what is known as indeterminate form. Indeterminate. I hope I spelled that right. Indeterminate form. Some people say that's IDF. It is not undefined. I need to be very clear. This is indeterminate. 0 over 0 could be a number of things. But we can't just leave our limit like that. It's not determined. So what do? I've got a terrible gimmick for you, even though I'm not a gimmicky guy. Here's how it goes. When you get 0 over 0, you look further. Okay, that's it. You look further. So 0 over 0, look further. Come on, it's fun. You got to try it. You know you're trying it at home at your laptop or at the beach on your phone or wherever you are. Definitely be trying that. I encourage you to. So what does that mean to look further? Well, there's algebra that we can do to break this thing down so we don't have to graph this thing out to figure it out. So I look at this and I think, wait a second, I could factor the numerator. That's the dead giveaway. So we plugged in a number and we said, well, hold on, we can factor this. I'm going to do this in a different color here. So I've got the limit as x goes to -3 of the factored form of that numerator there. So you're going to get x and x gives you x squared. The numbers that multiply to give you -15 that add to -2 are going to be -5 and plus 3. And that's all over x plus 3. All right, you got this. Let's keep going. So now you're not going to go and plug -3 in again. You're going to get 0 over 0 if we do that. What we're going to notice is that the x plus 3's can divide out. Nice. And so you're left with the limit as x goes to -3 of x minus 5. Okay, so what do we do from here? Well, if I'm going to plug in -3 at this point, I can, because I'm not going to get 0 over 0. So I'm going to evaluate this like that new limit. And so that gives me -3 minus 5, which is equal to -8. And that is our limit. It's -8. So what's the deal here? Why did we get 0 over 0 and then end up with -8? To understand this a little more and why this works, I'm going to show you a graph. But the bottom line is this, before I go into the why. If you get 0 over 0, look further. And in this case, what is often known as the factoring technique takes over. We know to use the factoring technique when you can, factor things. And then you look and see if common factors divide out. If, and normally when they do, you then reevaluate the limit at the number now that you've gotten rid of the parts that cause the 0 over 0. Okay. Now as to the why behind why this works and what's going on graphically. This graph of this thing is essentially the graph of x minus 5 with a hole at -3. That hole is caused by the 0 over 0 happening here. So I'm going to graph x minus 5. Very simply, we got a y-intercept at -5, and then I go up 1 over 1. So we'll graph this thing out. Now we're concerned with -3, so I'm going to bounce it down here. And remember, at -3, we have an open circle. So we'll just kind of sketch in a little line right in here. It's not going to be the best line in the world, but hey, it'll do. And we got the hole there. Now what you notice graphically is, as we approach from the left, as well as from the right, we are approaching a y value of -8. Is there a y value at -8? No, but we're approaching -3. And as we do from both sides, we end up with a y value of -8 that we approach, which is shown in our algebra. That's it. This just shows that there's a hole there. So again, to reiterate, if you're given a function that can be factored, Always start out by doing direct sub, plugging your limit x value in first. Then, if you get 0 over 0, we look further, factor it down, divide out the common factors, and now that you've gotten rid of the part that caused the 0 over 0, plug that number in again. It's a beautiful thing. All right. In another video, we'll go over the next couple of techniques that we can use when we get 0 over 0. I can't wait.